Academy. This is Deepak ME Structural Engineering AMI, a verified educator. So today we are going to start with the first lesson of the strength of the concrete course. Okay. So today we are going to see a general view on the strength of concrete, some of the important points and some of the important facts we'll be discussing about the strength of concrete here, which might be helpful for your examinations. But before that, don't forget to subscribe to the YouTube channel of the Academy. Also follow us to other platforms like app and the website of an Academy. So let's start. Hello everyone, good to see you. Hope you're having a great day. So today is the opening of the new course. Okay, so today we are going to see the very first lesson of our new course, the strength of concrete. So the opening batsman of our course will be a general view about the strength of concrete. All right, so let's see what is in there for us in this lesson. Well, as a civil engineer or a civil engineering student, the first word comes in our mind when we hear the word concrete will be strength. Okay, because strength has that much influence on the concrete. So first and foremost, let's see what strength is. So the literal word meaning of strength is the capacity of a material to withstand great force or pressure. Okay, that means to withstand a great intense pressure, to withstand a great crunch situation, it can be said as strength. Okay, so in case of concrete, when we refer strength, it will be mostly the compressive strength of the concrete, because concrete has been designed such a way that to take down the compressive force, or to let the compressive force pass through it to the next elements, and finally to the ground. Okay, and to the substructures and to the ground. So when we say, so once more, when we say about strength of the concrete, the most probably and generally it indicates the compressive strength of the concrete. Okay, so what is the compressive strength of the concrete? So it is one of the most important and significant and useful property of the concrete. This is based upon which almost all the elements of the concrete design is based. Okay, is designed. All right, it's based on the compressive strength, and also the mixed design of concrete is also based on the compressive strength of the concrete. So from that itself, we can understand how much important this quality of or this property for concrete is. Okay, so let's see what compressive strength actually is. It is the ability of the concrete to withstand the compressive loading. Okay, so that means when the concrete is undergoing a compressive loading, that is a loading from the upside, maybe downside, that is from outside to inside loading from the exterior, is known as the compressive strength. I mean the compressive loading in a very simple language. Okay, to make it understand. So to resist that, or the extent to which the concrete can resist, or the extent of the load up to which the concrete can remain in its original shape, or to remain its original dimensional qualities and the strength qualities, is known as the compressive strength of the concrete, or the ultimate compressive strength of the concrete. Alright, so that's it for the compressive strength. Now let's see some of the important points based on the compressive strength. Okay, so first and foremost, this is used as a measure for the other properties of the hardened concrete. Alright, so the quality of the hardened concrete is mainly based on its compressive strength. How compressively strong this concrete is, or compressively resistant this concrete is. So based on that, the quality of the hardened concrete is determined, or we can say it is a determining factor for a hardened concrete. Okay, in many ways, whether it is a practical way, whether it's a design way, this plays a vital role. All right, now the strength of the concrete is also the resistant to rupture. Okay, so that means that this can be also said as the resistance to rupture. All right, so what is it? And also it is measured in compressive, tensile, shear and flexural strength. That is, we all see, so the strength can be measured in different forms. Okay, that it can be measured as a compressive strength, it can be measured as a tensile strength, it can be measured as a shear strength, can be measured as a flexural strength for a concrete element. Okay, or for a concrete in general. All right, and we said that it is measured in different forms. There is another point, a very important point here. No exact qualitative relationship between important properties have been defined, but only approximate or statistical relationships have been developed, which means that there is no exact qualitative relationship was able to put forward between compressive strength and flexural strength, compressive strength and tensile strength, compressive strength and modulus of elasticity, wear resistance, fire resistance, or permeability. Okay, so they were not able to put forward a clear-cut pakka relationships between all these properties, but qualitative, statistical and or approximate relationships was the only thing was able to put forward. Okay, but these approximate values provide very good information for the design engineers. Okay, this you will be understanding when we are doing the designing of the concrete structures. All right, so that's another very important point about the strength of the concrete. Understand this paradoxical statement more. I'll give you a little bit examples. That is, the compressive strength increases when the size of the specimen increases. Okay, that is, the specimen size increases, the compressive strength also increases, but the modulus of elasticity decreases. Okay, so it's like an inverse proportion. And in some other cases, compressive strength doesn't provide a clear result in the case of freeze and thawing. All right, and also concrete containing about 6% of entrained dia, when relatively weakens in strength, is found to be more durable than and dense and than the stronger concrete. Okay, it's more durable and denser than the stronger concrete, but it doesn't have much strength. So it's like a lot of things are in inverse proportions. So that's why we couldn't able to. That's why it said that there is no clear-cut relationship is able to build between all these properties, important properties of the hardened concrete to be in generally. All right, now let's move on to next slide. In previous slide we understood that is measured in different forms. Okay, so how it is measured? So compressive strength is generally done by compression test with cubes or cylinders. This thing will be very much familiar to the final year students and also for other research scholars. That means almost all the compressive strength is done. Testing is done by cubes and cylinders, either in the compression testing machine or by using a UTM. Okay, so it is done mainly in the lab or it can be done on the field. Okay, or the cold drill from the hundreds of concrete on a site. Okay, and also the compressive strength sometimes can be determined by using the non-destructive testing. Okay, so those were some of the methods for testing or to measure the compressive strength. Now, the quality of the concrete is determined by its mechanical properties as well as the ability to resist the deterioration. So this ability to resist the deterioration can be said as the strength. Okay, so ability to resist the deterioration is also known as the strength of the concrete. Okay, now let's see what are these mechanical properties of the concrete. So this also is strength, but strength is also a mechanical property. So it's like workability only. It has every hand on its other properties, but sometimes it's quite confusing to define or to explain what it is. Okay, if you know more about it, it'll be more confusing. So it's very interesting. Let's see what it is, what they are actually. So some of the mechanical properties are short-term, that means instantaneous properties, long-term properties or sustained properties. Okay, it can be divided into two generally. So short-term properties, again, here comes the strength again under different states. Elastic modulus is there, bond characteristics is there. Okay, in the long term we have creep, we have shrinkage, fatigue behavior, durability characteristics, porosity, impermeability, abrasion, and freeze and thaw resistance. Okay, as far as the short-term process are concerned, strength of the concrete is the most important character. Okay, it's again coming in the short-term character as a short-term character too. Okay, so it has a strong relationship with the quality of the concrete. Okay, so again, the strength parameters is used for controlling as well as evaluating other properties of the concrete because its relationship with durability and stability and the dimension stability. Okay, so strength has a very direct impact on the dimension stability as well as the durability of the concrete. Okay, especially the dimension stability. And also, almost all the, as I mentioned before, almost all the structural elements and drawings are based on the compressive strength of the concrete if it is made from the concrete. Okay, see next slide. So we have seen the strength, we have seen what it is, we have seen some of the important points. Now the failure in concrete is another phenomena that we have seen in a lot of cases. Okay, so concrete failure is essentially due to crushing and shearing failure. Okay, this is not the factors but how it does fail, that is by crushing or by shearing. So in short, we can say that the mechanics of failure in concrete is quite a complex phenomena to explain actually. It requires a lot of in-depth studies and a lot of in-depth concepts to be gone on there. Also, while resisting the failure, okay, that's what you have to do with the concrete, it must resist the failure. So while resisting the failure, concrete generates both cohesion and internal friction. Okay, so both this cohesion and internal friction are directly related to the water cement ratio. That's why it is said that water-cement ratio plays a very vital role in the strength of the concrete. Okay. Now let's see modern water and cement ratio rule. So this is something like a thumb rule or something like a rule that is followed, this is an updated one actually, which I got from textbook. So what it states that for a given cement or concrete and acceptable aggregates, the strength may be developed by workable, properly placed mixture of concrete, aggregates and water under same mixing, curing and testing conditions, is influenced by ratio of cement of mixing water, ratio of cement to aggregates, grading, surface, texture, shape, strength and stiffness of aggregate particles, and also size of aggregates. So you wonder what we heard right now. So this is an general points about what are the factors that affects the strength of the concrete. Okay, so these are some of the very general points that affects the strength of the concrete. So from this we can take a small deduction. We can make a small understanding that water cement ratio is one of the most primer factors that affects the strength of the concrete, whereas all the other factors indirectly affect the strength of the concrete by affecting the water cement ratio. Okay, so all the other factors will affect the water cement ratio, and the water cement ratio will affect the strength of the concrete. So that's how it is done. So I hope today's lesson is helpful for you. Thank you once again for tuning in. Please comment your suggestions. Please rate my presentation. Please recommend and share the slides. This is my link to the profile to the Unacademy platform. I've done the courses on coarse aggregate, fine aggregate, cement, fresh concrete, workability, or factors affecting the workability of the concrete. So please do check that. It'll be helpful for you. So thank you once again. I wish you a great day. Until next time, ciao.